Hey everyone, we're going to look at a one-way ANOVA using JASP, and we're going to run this with two and only two groups. So let's get started. Let me share my screen with you. And here I have a data set on reading performance, on whether or not you got a directed reading intervention. And so the group that did, we call the treatment group, and the group that got treatment as usual is the control group. And the first thing we want to do is to check our normality assumption. And so I go to descriptive statistics, and I click on group as my independent variable, and my directed reading performance is in my dependent variable list. And because I have smaller sample sizes, I'm going to focus on that Shapiro-Wilks statistic right here. And I always like to produce box plots anyway and see what the box plots and QQ plots look like. But we can see that neither of these groups are less than 0.05. P is greater than 0.05. So these don't deviate in a meaningful way from a normal distribution. And you can see the box plots are fairly normal. A little skewness, but fairly normal. And the QQ plots for the control group and the treatment group pretty much demonstrate the same thing. There's some outliers here that we notice. We see those in the box plots as well. They're not real meaningful, but you know, and so we say this is an approximately normal distribution. And so with that in mind, I'm ready to run my ANOVA. And so from here, I'm going to click on ANOVA, and I'll put in my dependent variable here and my independent variable under fixed factors. And the first thing I want to do is check my model assumption to make sure that my variances are similar. And we can see, again, there's no statistically significant differences between my variances in my groups. So I can say we've met this assumption. If there was a problem, this p-value would be less than 0.05, and then I would need to run a correction by clicking this box and maybe interpreting the Brown-Forsyth test. But since no correction is needed, I can move on and say we've met the homogeneity of variance assumption, and I want to go ahead and look at, hit additional options, and I want to move my group over, I'm sorry, I want to go and click on descriptive statistics and estimates of effect size. And so here we see my means and standard deviations. I can copy this table and put it right into Microsoft Word, and I have a table in APA style. And then I have my estimates of effect size. We'll talk about that in a second. And so here, let's just take a look here. F of 142, those are my degrees of freedom, equals 5.14. P equals 0.029. There's a statistically significant difference between the treatment and control group. With a moderate effect size, 0.109, we move that decimal place over 2 spots, and I'm accounting for 10.9%, almost 11% of the variance in the model, which, if you recall, that's a moderate effect. A moderate effect was 0.059 was the cutoff. A large effect was 0.138, almost 14% of the variance in the model. This is about 11%, so approaching a large effect, but it's really a moderate effect size here. Now, I'm pretty much done at this point. If I were going to write this up in APA style, here's what I would say. A one-way ANOVA was conducted to explore differences in reading performance between a treatment group that received a directed reading intervention and a control group. An alpha level of 0.05 was utilized. Descriptive statistics are in Table 1. Groups were normally distributed. My variances were homogeneous. F of 142 equals 2.36, P equals 0.132. Let's take a look at where that value came from. That's right here. F of 142 equals 2.36, P equals 0.132. This is my assumption check. So now, a statistically significant difference was evident between the treatment and control groups. F of 142 equals 5.14. Again, let's take a look at where that value is coming from. If we look at our output here, and I'll just move this over. Yeah, f of 142 equals 5.14. I just rounded that up a little bit. P equals 0.029. A moderate effect size was noted at, oops, I have a little typo here, 0.109. There we go. 10.9% of the variance accounted for, indicative of a moderate degree of practical significance. And then here's my table. Now I put a little asterisk here because very often with two groups, it may only be it may be expressed as an independent t-test, which you can run with two and only two groups. It's a special case of ANOVA. And so if I wanted to show you what that would look like, I could just click here at post hoc tests, move group over, click on effect size, and we'll see the t-test results right here. F of, my degrees of freedom are the same. T of 42 equals 2.267, and P equals 0.029, the same P value. And my effect size is 0.684. Remember, in Cohen's D, an effect size can be expressed in standard deviation units. And so 0.2, 0.5, 0.8 for small, medium, and large effect sizes. And this would be still a moderate effect size, less than 0.8, but greater than 0.5. You're like, it's negative though. Does that matter? It just tells you where this is in favor of. That the lower group, that the control group is lower than the treatment group. In other words, when we look at the means, we see the treatment group scored higher than the control group. So I might even want to say a statistically significant difference was evident between the treatment groups and control groups. A moderate effect size was noted, indicating a moderate degree of practical significance in favor of the treatment group having higher scores than the control group. And there we go. And that concludes the tutorial on one-way ANOVA and how to write this up in APA style. So hope this tutorial was helpful.